Today, we are used to the idea that a day on Earth lasts 24 hours. Our clocks, our sleep, our work schedules, and even our bodies are shaped around this rhythm. But Earth was not always like this. Scientists have discovered that billions of years ago, a single day on Earth was much shorter than it is now. In fact, new research shows that for nearly 1 billion years, Earth's day stayed almost perfectly fixed at about 19 hours. This did not happen by accident. It was the result of a delicate balance between the moon, the sun, the oceans, and the atmosphere. This finding helps scientists better understand Earth's deep history, including how life evolved and why oxygen levels rose so slowly in the distant past. It also shows that Earth does not always change in smooth, simple ways. Sometimes the planet can get stuck in one state for a very long time. To understand why this discovery matters, we first need to understand why Earth's day length changes in the first place. Earth spins on its axis, and one full spin makes one day. Over very long periods of time, this spin slowly changes speed. The main reason Earth's rotation slows down is the gravitational pull of the moon. The moon pulls on Earth's oceans, creating tides. These tides are not just water moving up and down. They also create friction, which acts like a brake on Earth's rotation. This friction slowly steals energy from Earth's spin, making the planet rotate more slowly over time. Because of this process, Earth's days gradually become longer. Scientists estimate that today, a day becomes longer by about 0.02 of a second every century. This change is tiny and impossible to notice in daily life, but over millions and billions of years, it adds up. For a long time, scientists assumed Earth's day length increased in a smooth, steady way. In this simple picture, Earth spun faster in the past, then gradually slowed down as the moon continued pulling on it. However, when scientists began carefully studying ancient rocks, they found something surprising. Earth's rotation history was not smooth at all. Instead, there were long periods when the day length barely changed, followed by times when it changed more quickly. These flat periods are called plateaus, and one of them lasted an incredibly long time. The most striking plateau occurred between about 2 billion and 1 billion years ago, when Earth's day stayed very close to 19 hours for nearly a billion years. This was completely unexpected. You might wonder how scientists can possibly know how long a day was billions of years ago. After all, there were no clocks, calendars, or humans. The answer lies in rocks. Some sedimentary rocks form in layers that repeat in regular patterns. These patterns are influenced by changes in Earth's rotation, orbit, and climate. A scientific method called cyclostratigraphy allows researchers to read these patterns like a history book. By studying the spacing and repetition of layers, scientists can estimate how long Earth's day was when those rocks formed. Using this method, researchers gathered dozens of independent measurements from rock records around the world, covering the past 2.5 billion years. When they compared all this data, a clear pattern emerged. Earth's day length did not increase smoothly. Instead, it showed long flat stretches, especially the ones centered around 19 hours. The research was led by Ross Mitchell, a geophysicist at the Chinese Academy of Sciences. His work focuses on how Earth's rotation and orbital changes are recorded in rocks and how those changes affect Earth's long-term climate. Mitchell and his colleague wanted to test whether the traditional idea of a smoothly slowing Earth was correct. The rock data showed clearly that it was not. Instead, Earth's rotation sometimes entered special states where forces balanced each other almost perfectly. To understand why Earth's day got stuck at 19 hours, we need to look at two competing forces. The first force is the moon's gravity, which slows Earth's rotation through ocean tides. The second force comes from Earth's atmosphere. Each day, sunlight heats the atmosphere, causing it to expand and move. This creates atmospheric tides, which are large-scale pressure waves that move around the planet. Unlike ocean tides, atmospheric tides can actually speed up Earth's rotation slightly. This may sound strange, but the movement of air redistributes mass in a way that can give Earth a small rotational push. At most times in Earth's history, the moon's braking effect is stronger than the atmosphere's push, so Earth's rotation slows down. But under very specific conditions, the timing of atmospheric tides can line up perfectly with Earth's rotation rate. When Earth's day was about 19 hours long, the atmospheric tides reached a resonant state. This means their timing matched Earth's rotation in a way that maximized their effect. At this point, the atmosphere's push almost exactly canceled out the moon's braking force. Because these forces balanced each other, Earth's rotation stopped slowing down. The length of the day stayed nearly constant for about 1 billion years. This is an astonishingly long time in planetary history. This long period of 19-hour days did not just affect Earth's rotation. It also had a major impact on life, especially on the production of oxygen. During this era, most of Earth's oxygen was produced by photosynthetic microbes, especially cyanobacteria. These microbes lived in thick layered mats on shallow seafloors. During daylight, they produced oxygen through photosynthesis. At night, they consumed oxygen through respiration. The amount of oxygen that escaped into the oceans and atmosphere depended heavily on how long daylight lasted. Scientists including Judith Klatt studied modern microbial mats in laboratories to understand how ancient ones might have behaved. They tested how different day lengths affected oxygen production. Their results were striking. When days were shorter than about 16 hours, the microbes consumed more oxygen than they produced overall. Very little oxygen escaped into the environment. As days became longer, more oxygen was able to leak out. A 19-hour day was enough to allow some oxygen release, but not enough to cause a rapid rise in global oxygen levels. This helps explain why oxygen levels on Earth remained relatively low for such a long time during this period. Earth experienced a slow and uneven rise in oxygen over billions of years. One major increase, called the Great Oxidation Event, happened earlier, but after that, oxygen levels stayed fairly stable for a long time. The 19-hour day plateau may have played an important role in keeping oxygen levels modest. Because daylight was limited, microbial mats had less time each day to produce excess oxygen. This may have delayed the rise of oxygen-rich conditions needed for complex life. Once Earth escaped this resonant state and days grew longer toward 24 hours, photosynthetic organisms had more time each day to release oxygen. This helped set the stage for the later explosion of complex life, including animals. Although the billion-year plateau happened long ago, Earth's rotation still changes today, just on much shorter timescales. Modern atomic clocks are so precise that they can detect changes in day length of just fractions of a millisecond. These small changes are caused by shifting winds, moving ocean currents, melting ice, and even processes deep inside Earth. From year to year, Earth's day length can slightly increase or decrease. Scientists have also studied long-term measurements of Earth's rotation between 1962 and 2012. When they removed the effects of the atmosphere and oceans, they discovered patterns linked to Earth's liquid outer core. They found a regular 5.9-year cycle and sudden jumps in rotation speed that matched changes in Earth's magnetic field. These events, called geomagnetic jerks, are caused by movements of molten metal deep inside the planet. These findings suggest that Earth's core and mantle interact in subtle ways that can slightly speed up or slow down Earth's rotation. This research changes how scientists think about Earth's history. It shows that Earth does not always evolve gradually and smoothly. Instead, it can enter long-lasting states where powerful forces balance each other almost perfectly. The discovery of a billion-year-long 19-hour day reminds us that Earth's systems, the oceans, atmosphere, moon, and even life itself, are deeply connected. A small change in one system can affect climate, chemistry, and biology across immense spans of time. Even today, Earth carries the memory of its ancient past. The rocks beneath our feet still record the rhythms of ancient days. Microbes that once lived under 19-hour suns helped shape the atmosphere we breathe now. And tiny millisecond changes in day length still reveal movements deep inside the planet. The same Earth that once turned faster, paused for a billion years, and then resumed slowing. Is the Earth we live on today still spinning, still changing, and still telling its story to those who know how to listen?